Hey guys, I had a request to do a backwards problem, one where I tell you how much product I want to make, and then you're responsible for figuring out how much we should start with. In this problem, sorry, getting my BCA table ready to roll. We have sodium reacting with chlorine to produce sodium chloride, and I want to produce 581 grams of sodium chloride. So a lot of workers use this. Any business that's making any sort of product, right? You have to know how much inventory you need to buy to produce the certain amount. And Mr. C and I do this a lot as well, because when we set up labs, we know how much product we want students to make, so we have to figure out how much to start with, like how much of the Na should you mix with how much of the Cl. Anyways, what they're giving me here is sodium chloride, and that's how much we want to make. That's going to go down here after, right? We're always making product, but I can't put grams in my BCA table. So we have to go from grams of NaCl using mole island to moles of NaCl. So we start with what's given out in front, 581 grams of NaCl. There we go. And we need to divide that by the molar mass in grams. So let's find the molar mass of NaCl. It's 1 times Na, which is 22.99, plus 1 times chlorine, which is 35.45. Add those two pieces up, I get 58.44 grams per mole as my molar mass. So the 58.44 grams goes on the bottom, and so that's a division, right? 581 divided by 58.44, and I got 9.94 moles. So I want to make 9.94 moles of this guy, and we need to know how much sodium we need to start with, and they're asking about how much chlorine we need to start with. Okay, at the beginning, I don't have any moles to start, right? So I need a certain amount of Na, that's my question mark 1, a certain amount of Cl, that's my question mark 2, and I don't start with any of the NaCl because we haven't actually mixed it. I'm going to say, let's balance this equation. Sorry, I almost forgot the first step. So I see 2 chlorines on this side. That means I need 2 over here, so we put a big 2 in front. That gives me 2 Nas over here, so I need 2 Nas, and then we'll just leave a 1. So we're going to take minus 2 times X minus 1 times X. And on this side, we're making product, so plus 2 times X. Now we need to find what our X is. And normally we take, let me get my little pointer. Normally we take whatever this guy is divided by 1, and whatever this guy is divided by 2, and pick the smallest one as our X. Well, I don't know what those question marks are, so we have to use what is given, and I think this is what the student question was about. We need to use what is given to find X. Remember, the big thing with stoichiometry, B plus C equals A. So what if I wrote a little algebra equation, and don't panic because I said algebra. Look at B is 0 plus C, which is 2X, equals 9.94. We know that the 0 drops out, so then I really just have 2X equals 9.94, divide both sides by 2, and we are left with X equaling 4.97. So that is our X value, because that's the only information they gave us. That's the only way we can find X, right? So I'm going to say, go away, there we go, X equals 4.97. So this is going to end up being minus 2 times 4.97 minus 1 times 4.97 plus 2 times 4.97. Let's double check. Is 0 plus 2 times 4.97 9.94? Heck yes, it is. Now on this side, question mark minus 2 times 4.97, right? Question mark minus this has to equal our after. Well, if I want to know exactly how much is needed, right? The perfect dream situation where my hot dogs and my buns run out at the same time. Both of these need to be my superstars. I want them to both perfectly run out because I want to know exactly how much of each I need to remain. So this is a superstar and this is a superstar. So now can we find what our question mark is? Well, let's do this one first. Question mark 1 minus 2 times 4.97 has to equal 0. Well, question mark minus 2 times 4.97 is the 9.94 has to equal 0. So to get question mark number 1 all by itself, I'm going to add 9.94 to both sides. So question mark 1 has to be 9.94 moles. So I need 9.94 moles of the Na to start with in order to make 9.94 moles of the NaCl. And that makes sense to me because look at our stoichiometry. It's a 2 to 2 ratio. So every time I use 2 of these, I make 2 of these. I would imagine they should feel the same. Now let's try this guy. To find question mark number 2 minus 1 times 4.97 equals 0. So question mark number 2 minus 4.97 equals 0. We'll add 4.97 to both sides. So question mark 2 equals 4.97. So I need 4.97 moles of Cl2 to make 9.94 moles of NaCl. Does that make sense? Yes, because for every one Cl2 molecule, I make 2 NaCls. It would make sense that I need half as much chlorine to produce double the amount, right, of NaCl, because one molecule makes 2 molecules. So that's a good backwards problem. They do want us to do some conversion, so they want to know how many grams of Na we need. So let's do that real quick. Nope, I need all of you to stay. All right, so we got 9.94 moles of Na. To start. And then we also said 4.97 moles of the Cl2. And our equation was 2 NaS plus 1 Cl2 makes 2 NaCl. So part A says how many grams of sodium are needed. Well, I know that I need 9.94 moles of sodium. So all I need to do is go from mole island to mass island. And to do that, we are going to multiply by the molar mass. What do we multiply the molar mass of? Well, I'm talking about sodium, so it's all about sodium. The molar mass of sodium is 22.99 grams. Notice I don't care about the balanced equation when we're doing mole island. You didn't even know how to balance equations when we learned mole island. So 9.94 times 22.99 is 228.5 grams. So we can say 229 grams of Na. So I need 229 grams of Na in order to make the 9.94 moles of NaCl, which remember they asked originally for 581. So 228.5 grams of Na would make 581 grams of sodium chloride. And then how many liters at STP? So for this one, we're going from mole island to volume island at STP. And we know that 1 mole is equal to 22.4 liters at STP. So 1 mole on the bottom times by 22.4 liters. So 4.97 times 22.4 gives me 113.6 liters, or we could say 114 liters of Cl2. So I need this much in order to make that original request, which was the 581 grams of product. Hopefully this backwards problem was helpful.